So this is still Unit 2 and it's Learning Target 2. We're going to calculate the rate of change from a table. So in-class investigation, we're going to obviously do that in class, so don't worry about that. So right now, I want you to think of what independent and dependent means. Think about those words and pause it. Just think about what those mean. So our independent, if you're thinking of the word independent, maybe you're thinking of like your parents. In 8th grade, you're not really that independent. Independent means you pay for your own house, you pay for your own car, you pay for your own phone, you pay for your own things, you provide your own dinner, you buy your own clothes. You can do everything. You can survive on your own. That would be independent. Just like dependent would be probably what most of you are. You rely on your parents or your guardians or whoever to buy you things and buy your school supplies and buy your clothes. So now we're talking about this for x and y. So independent variable, it's going to be a variable whose values affect the values of another variable. I also want you to note that this variable can stand alone, so it can stand alone. It can survive on its own. It doesn't need the help of anything else. In a graph, I also want you to write that this is going to be our x value. So our independent variables are our x values. Independent variables are x values. I'm going to highlight that actually. It's our x value and it can stand alone. An example of this would be time. Time, we don't depend, like time doesn't depend on anything. Time's going to keep going. You can't stop time. It's always going to go and go and go. So that's why it's independent. It stands alone. A dependent variable would then be a variable whose values depend on the values of other variables. So this is going to be our y values. Again, I'm going to highlight that. That's important to know that these are going to be our y values. Our dependent variables are our y values. So an example for this, would be like maybe money, how much money you make in a certain amount of time, or distance, how far you can walk or how far you can run in a certain amount of time. So if we have a graph, right, these would be our independent and these would be our dependent, because these are my x's and these are my y's. Okay, so now we have this graph here, or this table, and so let's read this. The table relates to the approximate wind chills for different actual temperatures when the wind speed is 15 miles per hour. Assume the wind chill is a linear relationship for temperatures between -5 degrees and 35 degrees. So the first thing are, what are my independent and what are my dependent variables? So here's just a hint. Normally when you're given a table, most of the time it's given to you as x, y. Normally that's how they give it to you. So if we think about this, which one can stand on its own? To me, I think temperature is always going to stand on its own. It's always going to be this, but the wind chill is what changes. The wind chill is what changes. So my independent is going to be my temperature. My dependent is going to be my wind chill. Okay, so now we need to calculate my rate of change. So to do this, I need to find, remember, it's going to be my change in y all over my change in x. First, I'm just going to find out. So if I look at my x values, I can see that it's counting up by fives, and it's positive. It's counting up by fives every time. So my x values is going to go by fives. So 0 to 5 is 5, 5 to 10 is 5, 10 to 15 is 5. So here, though, I need to see how I'm getting from -25.8 to -19.4. So what I'm going to do is I'm going to subtract them. I'm going to do -25. I'm not going to do negative. I'm just going to do 25.8 minus 19.4. I'm going to get, that's an 8. I'm going to get a 0.4 need to borrow, and I'm going to get a 6. So I see that from here to here, I moved 6.4, but now I need to determine, did I move up or did I move down? Am I moving in a positive direction or a negative direction? Well, if I'm going from a big negative number to a smaller negative number, I'm moving positively because I'm getting closer to positive numbers. So if I do it again from here, you'll see that it's still a positive 6.4. So now I'm going to fill this in. So what I want to do is I want to do negative 13 plus 6.4. If I sing my song, same sign, add and keep, different sign, these are different. Different sign, subtract. So I do 13 minus 6.4. Need to add a decimal, need to add a 0, need to borrow. 10 minus 4 is a 6. Can't do 2 minus 6, I borrow again. 12 minus 6 is 6. So up here should be a 6.6. If you add again 6.4 to 6.6, you'll end up getting a 12.6. Add it here, add another 6.4 to, hold on, I did this wrong, didn't I? This should be a negative 6.6 because keep the sign on my bigger number. There we go. Because then when I add here, I'm going to get a positive 12.6. So that should be a negative. Don't forget to write that in as a negative. So then my rate of change, this is going up by a positive 6.4, is my rate of change is my change in y, which is 6.4, all over my change in x, and I saw that that was 5. So my rate of change is 6.4 over 5. Or if I want to, I can write it as a 1.28 if I divide it, and I already did that math. So let's interpret this. I'm not going to write the answer. You can write it. I'm just going to speak this answer out loud. So I can look at this. My rate of change is my change in y over my change in x, or I can even say it's my change in wind chill over my change in temperature. So if I look at it using this rate of change or this slope, I can say that for every 5 degrees that I go up, it feels like it's going up by 6.4 degrees more than that. Or if I use it over here, remember this would be over a 1, I can say for every degree colder it gets, it feels like it's 1.28 degrees colder than that. So it's going up, this here is now saying by 1 since I divided. So my starting value. Calculate and interpret the starting value. Remember, our starting value is where our x equals 0. And luckily for me, I have a spot right here where x equals 0. It's already given to me. So here, when x equals 0, my y equals negative 19.4. So interpret this. So all this is saying is that when it's 0 degrees out, it actually feels like it's going to be negative 19.4 degrees because of the wind chill. So now we write linear equation. So remember, this is y equals mx plus b. My b is my y-intercept, my m is my slope. So I'm going to start off like this. So m is my slope or my rate of change. So that's a 6.4 all over 5 with my x. And then here, I don't need to write plus because my y-intercept is a minus 19.4. You could have a plus and negative 19.4. So now before class, you're going to calculate and interpret the rate of change. What does it mean in terms of bottles and profit? And what about the starting value?